Venn diagrams are another way of working with conditional probability. Remember, the probability of B given A means the probability that B happens given that A has happened or happens. So we have the Venn diagram that we looked at in a previous video on basic probability of Venn diagrams. The Venn diagram shows how many pupils in a class like ketchup, brown sauce, or neither. We want to calculate the probability that a pupil likes brown sauce given that they do not like ketchup. Now, to do this, I'm going to look at my Venn diagram and I'm going to focus on the part of the Venn diagram which says that pupils do not like ketchup. This is going to be everywhere outside of the ketchup circle. So that includes all of this. So that includes the 6 pupils who like brown sauce but not ketchup and 3 pupils who like neither. So I'm going to restrict myself to just these 9 pupils. Now the probability, so basically I can ignore everything else. I can ignore the 10 and 5 in the ketchup circle. So the probability that a pupil likes brown sauce, given that they do not like ketchup, is going to be 6 out of 9, because there are 9 pupils in the specified region outside of ketchup. For B, find the probability that a pupil likes ketchup, given that they like brown sauce. It's the same trick again. Where it says given that says where I need to specify my restricted Venn diagram. So they like brown sauce, so that means I need to focus on so given that they like brown sauce, the pupil is going to be somewhere inside the brown sauce circle. So I need to restrict myself to this part of the Venn diagram. Now, in that part of the Venn diagram, there are 5 pupils who like ketchup. So my answer is going to be 5 out of how many people are in this restricted part of the Venn diagram, which is 5 plus 6, which is 11. Finally, to find the probability that a pupil likes both ketchup and brown sauce, given that they like at least one sauce, I need to restrict myself to the part of the Venn diagram which represents liking at least one sauce, which is basically anywhere inside the 2 circles. So the probability they like both ketchup and brown sauce means that they're going to be in the intersection. So that's 5 out of 10 plus 5 is 15, plus 6 is 21. So I'm going to do 5 out of 21. I ignore the 3 pupils who are outside of the circles because of this given that they like at least one sauce statement. Here's a question for you to try. Don't be scared of the fact that there are 3 circles. It's the same idea as before. Pause the video to have a go at the question, and when you're ready for the answers, press play. Here are the answers. Firstly, how many pupils are there altogether? For this, I just need to add up how many pupils there are. Okay, so we have 10 plus 8 plus 4 plus 3 plus 5 plus 7 plus 2 plus 6, just pays to be careful, and we have 45 pupils. For B, we need to work out the probability that a pupil likes squash given that they like tennis. Given that they like tennis means that I need to restrict myself to the tennis circle, and then within that look at how many pupils like squash. And I'm just going to get my highlighter. Now that's going to be these pupils here. So they like squash and they're in the tennis circle. So the probability is going to be 5 plus 7, which is 12, sorry. So it's 12 out of the total size of the tennis circle, which is 8 plus 4, which is 12, plus 5 plus 7, which is 24. So that's 12 out of 24, which is a half. For C, we want to work out the probability that a pupil does not like squash, given that they like badminton. If they like badminton, this, given that condition, means I restrict myself to the badminton circle, and then I need to look up all the pupils within that restricted Venn diagram who do not like squash. So they do not like squash, so they need to be outside of the squash circle. So that's going to be these pupils here. So the probability is going to be 10 plus 8, which is 18, out of the total size of the badminton circle, which is 10 plus 8 plus 3 plus 5. So that's 18, 19, 20, 21, 22, 23, 26. So it's going to be 18 out of 26. Given that a pupil likes at least one of the sports, find the probability they like all three. Now that looks like a tricky question, but given that a pupil likes at least one of the sports just means that they're going to be in the circles anywhere, that they're somewhere inside the circles. So we restrict ourselves to the circles and we ignore the 6 on the outside. The probability they like all three, well, to work that out, we need to look at a pupil who likes badminton, tennis, and squash, which is going to be the 5 pupils in the intersection of all 3 circles. So the probability is 5 out of how many pupils are inside the 3 circles, which is 39. So our answer there will be 5 out of 39. Finally, for E, given that a pupil does not like squash, calculate the probability they like badminton. To work this out, I need to focus on the part of the Venn diagram which says that pupils do not like squash, which is going to be all of this. So that includes the people that like badminton but not squash, people that like tennis but not squash, and of course the 6 who like none of the sports. So that's what I'm restricting myself to. Now within this, there are 18 pupils who like badminton. So it's going to be 18 out of all of the highlighted areas, which is 10 plus 8, which is 18, plus 4, 19, 20, 21, 22, plus 6, which is 28. So my answer would be 18 out of 28.